So hi everyone, today is 10th of January and welcome back to the channel. Today we are going to solve another daily problem of the LeetCode, which is the same tree. So this question is regarding the binary tree and how we can see that whether the two trees that are given, the binary trees, are equal or not. So the prerequisite is you should know what is a binary tree and how to travel a binary tree. So yesterday I have told you and code you, like I've told you the traversal ways: in order traversal, pre-order traversal, and post-order traversal, in which we have solved the pre-order traversal. So you can check out that video also. In this video also we are going to travel the tree using the pre-order traversal. Okay, so first of all, let me just discuss what is given in the question. So we have given a binary tree P and Q. So these are two binary tree and we have to basically return whether it is similar or not. Okay, so for this same or not, the two trees should be structurally identical, first condition, and the nodes should have the same value. This is the second condition. So you can see in this example we have 1 1, 2 and 2, and 3 and 3. So it is identical in both ways, structurally also, and nodes, the value of nodes are equal. So this returns true. Okay, in example 2 we can see that this is 1, this is 2, this is 1, and this is 2. So the values of the nodes are actually equal, but you can see that the structure is not equal. This is the left of this root and this is the right of this root, so that's why we are returning false. And in example 3 you can see that the structure is similar but the value of the node, this 2 and this 1, is different. Okay, so that's why it is false. So I hope you get the question. Let's just go to the Scalidraw. There are two ways to do this question. First one is the iterative way and second a recursive way, and second one is the iterative way. Okay, so let me first discuss the recursive method. In the recursive method, what we'll do is we're going to do a pre-order traversal, and in pre-order traversal you very well know that we first perform the operation or do what we want, which is basically the root. Okay, and then what we'll do, we'll travel to the left of the tree and then we'll travel to the right of the tree. So in this question only, what I'll do is, first of all, I'll we have this root. Okay, so we'll check whether the roots of these trees are equal or not. If they are equal, then we'll return true. Okay, and then after returning true from it, we'll travel to the left of both the trees. Okay, so we'll travel the left of this tree and left of this tree, so we'll come here. So after coming to here, we'll check that whether the left are equal or not. If they are equal, then we'll return what? Return basically true. So this value will return true. Okay, so this will return true and this also will return true. Okay, so here we also have true returning. After that we'll travel to its right. Okay, so after traveling to its right, we'll reach here, and on this we'll reach here. So after traveling to its right, we'll see that whether the values are equal. Yes, the values are equal, so what we'll return true. So okay, let's just return true, and here also we'll return what? We'll return true. So okay, so now what we'll see that we are having true both the side, and this is also equal. So the ultimate answer that is being returned is true. So you can see that this is the structure and this is structurally equal, and as well as the value of all the nodes are equal. So let me just go to the code and tell you, and it will be more clear after seeing the code. Okay, so in the code itself, first of all, what I am checking, if p equal to null and q is equal to null. This is the first condition. If both the roots are null, so what will return? We'll return p equal to true, which is true. Okay, because both the root nodes are true. Again, this is the condition. You can break it down also, but I have written in the same line. Now let me explain you what I have written. I am checking p value, which is this value, if it is equal to q value, this value. Okay, if it is equal, then it will return true. Okay, so this is the case. Like this one is the operation is this. First of all, I am trying to do this one. Okay, now after doing this, what I am checking, I am taking the condition n and n. Now why n and n? Because I want everything to be true, then only I'll return the true. Now I'm calling the function. Here the recursive call is there. Now what I am doing, I am going to the left and Q's left. Okay, P is left and Q is left. So I'll reach here after this, and after this I'll reach here. Okay, so again I'll go to this function. Okay, now again it will check whether it is null or not. It's not null. Okay, so what it will do, it will go here and it will check whether P's value is equals to Q's value. Okay, yes, it is equal. So here also it will return true. Now what I'll do is, now it will also travel to its left. So after it will go to 2's left, and here also it will go to 2's left. Again this function will be triggered. When the function will be triggered, it will see that, yeah, P equal to null, yes, and Q is equal to null, yes. So what it will do, it will return P equal to Q, which is true. So it will return to here. After returning, and after this, what is there, this is sample tree right. So it will travel to 2's right. Okay, so it will travel to 2's right, and here also 2's right. Okay, so this way it will be more clear. Like after returning this here, after returning the null, what it will do, it will go here and check the right. Okay, and after checking the right, what it will see that it's null, so it will return true. So here also we'll be getting true. Okay, so true and true. Okay, so I hope you get the point. From both of these nulls we'll get the true, and this will return true. And similarly we'll travel to 3. Here also we'll travel to 3, because the right part, after returning true from here, the right part is left, so the code will run. Again, when the code will run, it will see both the values are equal. Then we'll go to 3's left, and then we'll go to 3's right, and after going in both of these directions, left and right, we'll see that it's true. Okay, because null, so true. So after returning from all these things, everything in this return value, this will be true, this will return true, and this will return true. And when all the things are true, automatically the function will return us true, and these three, it will get identical. Okay, so this is the thing that I just wanted to tell you. After that, the other approach is the iterative one. So this approach is the iterative approach. In iterative approach, what we'll do, we'll make a stack. Okay, so after making a stack, what we'll do, we'll push the values inside the stack. So let me explain you how I'm going to push the value. So we'll push 1 and 1 inside this stack. We'll push them in pairs. Okay, and again we'll check that these are equal or not. If the stack is not empty and these are not, these are same, then we'll return true. Otherwise, if they are not same, okay, then we'll return false. So let me just go to the code itself first of all of this iterative method, and then I'll explain you like what is happening. Okay, so with the code you will have greater understanding of what's happening. So let me go here in the iterative one. So you can see that we have making a stack. Inside the stack, what we are storing a pair. Okay, pair of the type tree node. Okay, and this is to basically refer to this stack. Now we are pushing what? We are pushing P and Q. Okay, after pushing P and Q, we are seeing that while the stack is not empty, we are coming into this while loop, and after that what we are saving in the stack.top, we are saving this one. Okay, and we are popping out from it. Okay, so after popping out, we'll see if not node and not node 2, if it is null, then to you should continue. Okay, and if not node, if one of the condition is getting false, then it doesn't means like we have to make all the things to be false. Okay, in this condition. So if not node 1, not node 2, and not node 1 values is not equals to not 2 value, then we'll return false. That what I am saying. Okay, in the stack itself, we are seeing that whether the values are equal or not. Okay, and after that what we'll do, we'll push node 1's value the left of it, and the nodes 2 left. Okay, so we'll travel whole left, like we'll push the left of the left into the stack, then we'll push what, we'll push the right into the stack, and again this code will run, and that's how we are able to check, and at each stage it will return true or false based on the condition that we are having. Okay, and at last, basically after the continuation part, after that, after coming out of this loop and we have not encountered this condition at any point, then what we will return, we will return true. So I hope you get the question and you got the approach. I know the recursive approach is very easy and short, but for the interview sake, I have also told you the iterative way in which we are going to use the stack. So if you like this video, make sure to subscribe the channel. We are going to post daily on this channel. So thank you so much. Bye.